Yes, Melis, we can hear you.
Thank you. Okay, so good evening, ladies and gentlemen. I warmly welcome all of you to the knowledge sharing session conducted by the Sri Lanka Society of Transport and Logistics on the topic AI in the front seat, rethinking transport and logistics with artificial intelligence. SLSTL aims to create a professional environment to discuss the issues in the transport and logistics industry and to recommend sustainable solutions to develop the industry. Today's event is one such platform. As you can see on your screen right now, the aim of today's session, the transport and logistics sector, the transport and logistics sector faces persistent challenges, including dynamic traffic conditions, operational inefficiencies, and escalating costs, all of which demand innovative solutions to enhance performance and resilience. This talk aims to discuss the potential of artificial intelligence in the context of transport and logistics, presenting use cases and ideas for innovation. So during the session, we have a kind request from all of you. As you can see on your screen, I will share this link in a few minutes on the chat. We would like all of you to fill this form for us. This is your valuable feedback, which we will be using to further develop and enhance our programs. Today's resource person is Dr. Damayanti Herath. I warmly welcome Dr. Damayanti Herath on behalf of Sri Lanka Society of Transport and Logistics. We also have with us today a couple of senior council members from SLSTL. Professor Amal Kumarage is with us, the founding president of SLSTL. We have Dr. Vasantha Wickramasinghe, the vice chairman of events, who has organized this event today. We have Dr. T. Sivakumar, Senior Council Member, and we have Dr. Indika Sigira with us, Treasurer, SLSTL. So hopefully we'll be having more council members join shortly. Dr. Damayanti Herath serves as the Director Engineering Education Unit and Senior Lecturer at the Faculty of Engineering, University of Peradeniya, Sri Lanka. She holds a BSc Honours in Computer Engineering from the University of Peradeniya and a PhD from the Melbourne School of Engineering, the University of Melbourne, Australia. Her research expertise spans computational intelligence, omics data analysis, and edutainment, with a robust publication record and numerous presentations at international conferences. She is currently leading the Data Engineering and Research DEAR group at the Computational Biology CompBio group at Peradeniya. I wish you all a very productive session. Over to you, Dr. Damayanti.
Hi, good evening, everyone. It's always a pleasure as well as exciting to a group of people that are not really, a little bit distinct to your field of work. I'm extremely grateful to the Sri Lanka Society of Transports and Logistics for giving me this opportunity to talk on this topic. And I was thinking to start off with my introduction, but as it was given already, I will not repeat. And everything about myself, most of the things about myself and what work am I doing is it's available through my personal website, damayantiherath.net. And yeah, I'm a senior lecturer at the Faculty of Engineering, and I'm also serving as the Director of Engineering Education Unit. All right. So let us imagine that you have had a very rough day and you are having a lot of data, lot of hard files to process. You are processing through different suppliers' information. You are trying to track deliveries, and then at the same time, your boss, the immediate supervisor, is asking you to send in a couple of reports. Maybe even though I said as imagine, maybe it's the reality of one of yourself as well. I don't know. But imagine at the same time that you had a very close assistant that could assist you with some of these tasks that you are struggling to complete. Not really struggling to do, but struggling to complete on time. And imagine you had an assistant, like a personal assistant for yourself, who can help you with these tasks. So apparently, not apparently, artificial intelligence is that is what it is promising us, that it can be a personal assistant for us. And so, for example, this is how it is helping in the AI is helping or is promising to help in the field of transportation and logistics. Let's go through the video as an intro to the session.
I am a navigator. Transforming autonomous deliveries for the long haul and the short trip to our front doors. I am simplifying travel, making it easier to reach our destinations, and giving us a safer ride home. I am connecting us like never before, making every trip more personal.
Hey, Mercedes.
How may I help you?
I'm tired.
I will turn on the Vitality program.
And every journey more effortless. I am driving amazing experiences.
Welcome to Driver Coach Demo. Keep close to the right edge.
Freeing us to take on exciting new challenges. And letting us explore incredible new worlds.
Yeah, that's quite promising. And is it really possible, or how can we be on board? That's what we are going to discuss. But before we go there, so that is what we are going to discuss. How can we bring AI to the front seat, especially in the field of transport and logistics? And before I go there, would like to have like a quick introduction to the session participants. And for that, I created this quick poll. So I invite you all to, not sure if you are in front of a laptop or if you are able to access your mobile phone, please either scan this QR code or you can go to menti.com and use this code. And let's introduce us to each other. Listen mode. So this is the QR code. Yeah, the first question is, it's asking to give us a few keywords for your current designation or role. I hope the audience is in the field of transport and logistics, but what exactly are you doing? Yeah, I see some results are coming. And the next question is, how familiar are you with AI? We'll take a minute. So it looks like we have a mix of industry and academia, senior lecturers, academics, researchers, and postgraduate students, and also transportation engineers, transport planners, who are probably coming, bringing back the expertise from industry. The next question I had is, how familiar are you with AI? Next question is, do you think that AI will take over your job? Yeah, I actually could not add a not sure answer, it seems, but yeah, either yes or no. Yeah, please keep them coming. I'll check it again sometime. And this talk within this short period of 1 hour, I hope to discuss because looks like most of in the forum, most of us in the forum are somewhat familiar with artificial intelligence. So with that assumption, I'll do a very quick introduction into artificial intelligence, what it is, and then present some of the use cases where possible use cases that AI is used in transport and logistics. But my ideal objective is that ideally I'll be able to assist you in figuring it out yourself, whether I can use AI in my scope of work. And then hope to conclude with a discussion on the way forward. So as this cartoon depicts, how did you get the budget approval for all these? I just told them the name of the project. So everyone is talking about AI these days, and it's also been like a, if you like a flashy term to market a project that you're having. I hope most of us would agree. So what exactly is artificial intelligence? I'm going to give a very brief, as well as an very abstract view of artificial intelligence. We have been talking about artificial form of intelligence, I think since around we have evidence, so we can go through the documents and see what we have been talking about since 1600 or 15th century. We would have been talking about, can we build an intelligent system, but that is artificial. So it's a topic that we have been talking for a long time, if you look at the history of artificial intelligence. But most of the work, some solid work was initiated by the conference in 1956, the very famous Dartmouth Conference, where the researchers across the globe got together and they decided we need a definition for artificial intelligence. And they brought forward a very solid definition for what is artificial intelligence. So this might be very different to how we perceive AI. Different people perceive AI. But however, the definition that we formed in 1956 in the field of computer science, if you like, is that it's the science and engineering of making intelligent machines. So in that sense, in fact, it's a very, very simple definition. Artificial intelligence is the science and engineering of making intelligent machines. What makes it complex and very interesting to most of us is how do you define intelligence? So, because the definition has an intelligent machines part. So how do you define intelligence? What does it mean to be intelligent? One of the key papers that stand out, key research publications that stand out, one of the key questions that have been posed to us who are working in artificial intelligence came in the Alan Turing's manuscript. Famous Alan Turing, who helped solving who built the Enigma machine during World War II to depict secret messages from the German army. And the question he asked was, the problem he posed was, can we develop a machine? He developed a problem that is very commonly looked at in the field of artificial intelligence is, he said that you can say that you have developed an artificial intelligence systems. If you have two systems, one is human, one is a artificial system, and you give it to a human to assess. And if you come to a point where that human cannot say a difference between whether it's a human or a machine, we could say that we have achieved artificial intelligence. So that is like one of the key primary early ideas of artificial intelligence, but it has been keep evolving, and in a way, we are pushing the boundary of how we define intelligence. At the beginning, maybe if you look at around 5 decades before, the intelligence was about maneuvering in a factory without hitting an object. Fast forward a few decades, the intelligence was about forecasting what will happen tomorrow, forecasting the sales, the revenue that will be generating tomorrow, a predicting task. But fast forward to today, where we stand, intelligence can be the ability to manipulate language so that you can generate summaries, you can develop reports, likewise. So in the future, or even now, what we are trying to do is we are trying to push the boundary of how we define intelligence. And so which results in which has resulted in a new revolution, which we termed as the 5th Industrial Revolution. And to very briefly present you the techniques that we are using in artificial intelligence field. If you are interested, I hope we are all familiar with a tool like ChatGPT, is based on a particular technology called large language models. And that is based on a particular technique called generative AI. Generative AI can also be considered as it's one of the machine learning techniques. So there are many more machine learning techniques. One of them is generative AI, which is mainly you give a prompt and you can instruct the AI what to do. And it can generate, so you give a prompt to the AI and the AI can generate new text or images or videos based on the prompt. Machine learning, generative AI, large language models, all of them falls under the very big umbrella of artificial intelligence. There are a lot of things more than, for example, GPT that we talk in the field of artificial intelligence. But of course, at the moment, there is a lot of focus around on large language models and generative AI, but it is coming under as one of the techniques of artificial intelligence. And this is a one categorization we could give in terms of artificial intelligence. But we can also give another classification for artificial intelligence. I term it as alternative intelligence because as I said, decade by decade or day by day, we are integrating AI into our lives a lot. And then, in fact, it's not really artificial anymore. We can view it as an alternative form of intelligence. It's my like a personal favorite way of putting artificial intelligence into a perspective. And the idea is, in fact, you can identify different roles of artificial intelligence. I think it is if you are thinking of in a particular domain and trying to understand where I can apply artificial intelligence, it would be helpful to be aware of these different roles that artificial intelligence can play. So the artificial intelligence can play the role of repetitive. So the idea is it's automating a repetitive task. Or it can be termed as a predictive system, or it's assistant intelligence. So the idea is you don't rely a lot on the machine or the artificial intelligence or the system, but it supports you to make some decisions. It can be termed as predictive intelligence or assisted intelligence. So it's just, we use its output but everything is done by the human. Most of the work is done by the human. We rely a bit on the intelligence system. The step forward, in fact, the era that we are looking at is the augmented intelligence. That is, it's like AI is working with me hand in hand. It's like I have my own personal assistant, and it's augmenting some of the tasks that I would do, and we are working hand in hand. And I rely a lot more than assisted intelligence when I talk about augmented intelligence. Autonomous intelligence is it's almost zero human input. Everything is autonomous and it's done through artificial intelligence. This is where we talk about artificial general intelligence or fully autonomous, where the idea is we don't have human input at all. AI works on its own. So to elaborate further, as I said, it will be, if you're thinking of a problem, if you're thinking of a scenario, one way to look at it would be to look at, okay, what is the role AI can play? Is it repetitive? Is it predictive? Is it prescriptive? Or is it adaptive? So as an example, the repetitive task would be something like this. So it's an example where DHL is, so you want to sort the items in your warehouse, and it's a repetitive task, and you know exactly what to do, what is the path to take, and there is very little risk involved. The errors are bearable. You can leave some space for some errors. So you can consider, okay, I can automate it. It's a repetitive task, a routine repetitive task. I can use AI to automate it. So this is an example, what you're seeing in the screen. I'll let you see it. It's an example where DHL is using using artificial intelligence to do the sorting. So they have automated it, this repetitive task. Whereas the predictive task would be, for example, you use a machine learning model, or you use okay, machine learning is part of artificial intelligence, so I can use that in that way. You use a machine learning model or some sort of a AI system which will predict you, which will forecast what is the expected time. For example, as shown here, how Uber is using a predictive system. So there, human input is higher or more than the input from the artificial intelligence system. We use it as a decision support system, but it's not really working hand in hand with us in this task. We take, it's giving an out, we are relying on we are maybe we are relying on deriving some of the information that is required for us to make a decision, and then the human makes a decision. So this is how Uber is, for example, using this predictive system. So we have the Uber services. They have a service running to do the estimated time and some machine learning model. And the output is passed back to the Uber services, and they are using it at the final decision to figure out where to send which device, or where to send which vehicle. Whereas in augmented task or the prescriptive, the augmented scenario, I would think it's a very relatable. If you're working with a tool like ChatGPT, what you're doing is you are in an augmented scenario where you can ask questions from the model, and it's working hand in hand as an assistant. And this is an example. Maybe the experts who are working in the logistic industry are already familiar with this. There's a software called Blue Yonder. The agents at the moment, when someone talks about the agent, what they are referring to is an AI system that is using a large language model. So basically, you are manipulating or you are working with that artificial intelligence system through language. You can prompt them and get things done. And here, the Blue Yonder, what they are suggesting is you can outsource some of your tasks in your logistics sector. So things like maybe detecting anomalies, or maybe predicting the demand forecast, or like things like that. You can outsource to an AI system, and you relax. And then the AI system would alert you. If there's anything that needs human action, the AI system will alert you. So it's working hand in hand with the human.
What makes our agents really different, as you always say, is that they can both see and act and touch the physical world. And this is how we will truly get to the autonomous supply chain, orchestrating the world at machine speed and precision.
Let's get into the actual Blue Yonder agents. The first agent we're going to talk about is our Shelf Ops agent that is powered by our large planogram model. And the Shelf Ops agent brings a new level of speed and precision to category management. It enables planners to generate and edit planograms at massive scale using natural language prompts.
And now our agents, powered by the Blue Yonder orchestrator, will directly connect to the physical world through our application APIs and events. These agents will change not only the digital world, but the physical world also.
Let's talk about the Warehouse Ops agent.
The Warehouse Ops agent actually performs deep root cause analysis of the transaction data itself, and it uses this understanding to recommend targeted solutions to complex and even systemic problems. It empowers warehouse managers to interact with slotting optimization dynamically, enabling them to understand and validate and act on AI-driven recommendations in real time.
The next agent is the Inventory Ops agent.
The Inventory Ops agent acts as a digital planning analyst, empowering planners to understand demand forecasts, inventory strategies, and supply plans.
Next, we have the Network Ops agent. So the Network Ops agent basically handles this complexity and provides real-time recommendations to resolve issues and situations as they arrive. And then our final agent announcement today is our Logistics Ops agent. And this agent provides deep, actionable insights into your transportation plans to unlock sort of hidden opportunities, bottom line improvements, etc.
And it uncovers root causes behind unroutable shipments, enabling faster and smarter decisions.
So all those agents that they are talking about, as they also mentioned in that intro, is that they are, it's as they correctly sound like, the human can offload most of the work to these AI systems, and these agents, they are working based on natural language instructions. So that is an augmented scenario, or the prescriptive role of the AI. The other role of AI is that it's completely autonomous. And I think 1 or 2 weeks before, of course, you would be aware of this. Somebody in China, they reported that now they are doing self-driving taxis. So something like that is completely automated.
I'm at the designated waiting spot, waiting for my Baidu Apollo Go taxi to pick me up in Wuhan. It says it's 3 minutes away on the app, so I'm poised and ready. Hello, it's Will Glasgow, the Australian's North Asia correspondent, coming to you from Wuhan, from a robot taxi in Wuhan actually. I'm in one of the almost 400 of these taxis that are run by Baidu, the big tech giant here, China's Google. And I'm in one of them doing to be honest, a kind of random trip. In Wuhan, about 1/3 of the city you can use these robo-taxis in, or they're allowed to cover about 1/30 of the city. That seems to not include point A to point B of almost any trip I'd actually want to do in Wuhan, but I'm in here just for the fun of it to check it out. So I waited at my designated spot, put in the QR code to open up the door, and then now this robot, this empty seat, is driving me through a city as big as Sydney and Melbourne combined, more than 10 million people. So what could possibly go wrong?
That's amazing, and that is very exciting, and it's it's exciting for sure. It's exciting, right? So what you're seeing here is the adaptive behavior, or the fully automated, autonomous behavior of AI system. So we can take a minute, we can take some time. So I would invite you, if you are having any routine task, or if you have any problem, and if you are working on a particular scope, maybe you can think one thing, if you're wondering how I can adapt AI in my scenario, would be to think of, is there an automative task? Am I trying to automate a repetitive task? Or I want to develop a system where I need some support to make decisions. So I'm looking at a forecasting model or a prediction model, some model to help me to make the subsequent decisions. Or am I looking at a system where I can interact in natural language, or I can manipulate language and I can get things done? Or am I looking at completely autonomous system where everything will be autonomous, very little, almost none human input? So yeah. And so these are the things that is happening at the world. I think if you look at AI, the field of AI, a lot of focus, actually what we are calling now is actually mostly it's machine learning. We are terming it as artificial intelligence, but it's mostly what we are doing is machine learning, working with data. And at the beginning of the field, what we were focusing on was more of predictive tasks. But now we are able to manipulate the language, and we are looking at prescriptive tasks. The future is told to be more adaptive, where we are looking at more and more autonomous systems. So how are we adapting these technologies
I'm at the designated
fields? I will present some of the use cases from the Department of, from the Faculty of Engineering, University of Peradeniya. Actually, the Department of Computer Engineering is actively collaborating with a lot of entities, not only myself, but the other staff members as well. So one of the work we did with the a group at University of Melbourne was using gyroscope data to detect sobriety. The idea was because they wanted to incorporate, for example, like a bike riding, bike share. So you know, it's very common. You can have it's not very common in Sri Lanka, but in other countries, you can just take a bike and then do your trip, and then again lock in the bike, and you will be charged and you will be done. You don't really have to own a bike yourself. But the problem we were looking at is this was about analyzing the behavior of those riders, and whether we can use gyroscope data, some sort of sensor data, to detect whether they are drunk or not, which can be used to, which can be related to the road safety. Another example is where we looked at we worked with Department of Civil Engineering at Faculty of Engineering, University of Peradeniya. What we were looking at is developing an agent-based model to understand whether we can introduce micromobility for a country like, for example, Kandy. Can we introduce micromobility? Micromobility is the vehicles that are less than 350 kilogram weight, and they can run on the speed of the maximum speed of 45 kilometers per hour. And how to model to decide based on our road conditions, our people's behavior. If we are to introduce a micromobility, like we recommend passengers, recommend people to use bikes or ride on bikes, what are the scenarios we need to consider? So this was the problem that we were looked at, and how sensible it would be. And another problem that we are looking at, which is also a collaboration with the RMIT University in Melbourne, Australia, is travel time prediction. Of course, it's not the travel time prediction that we see in Google Maps, which is done on real time. But in contrast, whether we can have a model to support us to do travel time prediction. For example, if you are trying to make decisions, if you are a transport authority, and then you are designing the next the transport system or the infrastructure for a particular city, you would be interested in knowing travel time. And the objective is to use these techniques for travel time prediction problem, but of course in the context of Sri Lanka, which introduces some unique problems. We know us being a still developing country, we have it's not as straightforward as riding on a smooth road. We have a lot of variables to consider, and a lot of variable scenarios to consider. So it's a challenging problem, and we are working on this problem, looking at in a perspective of artificial intelligence, using artificial intelligence to solve this problem. So these are some, I would say, use cases or applications of artificial intelligence. And I think the framework, the model I can recommend would be to look at, identify what sort of role I would like the AI to play in my work. And what sort of benefits it would be good to be aware of. Why should I adopt artificial intelligence? Yeah, it looks like it can do a lot of things and it's very interesting and exciting, but are there any benefits? Yes, there are benefits. So the main thing is there are a number of benefits that we can identify. And here I'm listing a few. One is it can enable us to do smart decision making and prediction, especially with the use of Internet of Things, where we are using sensors, sensing and communication to gather data. We can develop things like smart traffic systems, traffic control systems, or we can look at developing more safe roads for pedestrians if we can gather data from these smart systems, and they can help us in decision making, developing new infrastructure. And it can also help in risk management and reduce the cost by helping us with route optimization. For example, identifying what is the optimal route to take for a certain delivery, or maybe predicting the demand, forecasting the demand for the future, so that we can be ready in advance. And it can help with, of course, it can have the benefit of dynamic pricing, and which will lead to better customer experience. Of course, in terms of sustainability, if we can optimize, if we can use these AI systems to optimize the traffic flow, and for example, as an example, if we can optimize the traffic flow and then by which we optimize the energy used by the vehicles and efficient use of the vehicle. We can go for which can lead to sustainable solutions for our problems. And of course, the benefit would be less manual work. It's not only about the labor here. Actually, if you look at some of the tasks, I think the highlight should be around the errors that we could make. With the one drawback that comes with manual work is it can be erroneous, because we humans get tired and we humans get moody, we humans get upset. So that can affect our productivity. Whereas these automated systems, AI systems, whether it's good or bad, I don't know, but they don't get moods, they don't get tired. So at the same time, as a result, the error rate could be less than compared to doing manual work. More than the labor involved or the number of manual hours that you are cutting off, I think the benefit would be the error rate that you are minimizing through these systems. So it sounds like there are a lot of benefits of AI, and of course there are convincing stories of benefits of AI. I wanted to the forum to try this out, but maybe it's all something that you are already familiar with. What I wanted to demonstrate is I had a small data set here. It's a very small data set. Something like this. Maybe this can be your delivery report where you have some items being delivered starting from one location to another. Yeah. And then you have how many, what was the date and how long it took. And imagine in the maybe 2 years back, we would have to manually process this sheet. Maybe we had to manually enter this information into an Excel sheet first. We had to manually enter these details into an Excel sheet first, and then we had to manually process them. But now we don't have to do that. We can, there are enough and more analysts support for us. For example, give me a second. Okay. We can very easily go to a tool like ChatGPT and then attach this, download this file and attach it here, attach it as a document. And then we can ask questions like, we can use natural language and ask questions like, what is the average delay for each delivery mode? We can ask questions like, list the top 3 origin destination pairs with the highest average delay, or we can ask it to create a line chart showing the average delay by date, or we can ask questions like which route have 0 delay, things like that. Of course, we can also ask it to summarize and generate a report. So how I would do that is, yeah, we call this as a prompt. So summarize the attached data sheet for sheet, highlight on the delays, identifying the corresponding fields. Of course, I can do some mistakes in the prompt, and yeah. So and there are a lot of general models as well as specialized models, specially focused on transport and logistics. If you have a particular task, for example, if you're looking at warehouse management, if you're looking at the stock management or delivery management, you can look up Gen AI tools for this particular task. Of course, you can ask ChatGPT itself, what are free or pro software applications for me to work on these things. And then there will be a lot of generative AI tools that enable you to do this kind of tasks. And the specialty here is, as I said, they are working in the augmented mode. We can interact with the AI system through natural language. And now, one of my friends who is in the industry was telling, in fact, the only programming language you have to learn is English. I don't know how much even I myself agree with it, have to think about it. But the idea is it turns out now you have a very good knowledge base, if you would like, that has been trained on already known, already collected, already existing knowledge. And you can prompt that knowledge base. You can search through that knowledge base. Previously, you had to do a Google search and you have to get the documents yourself and do the work. But now you can get what you want out from this knowledge base by using natural language, by using simple, plain English, sometimes your own mother tongue, and through a prompt. And prompt engineering is what you have to master if you want to know how I effectively get things out or get things done from this particular tool. But I would also want to highlight the fact that I highlighted these models were trained on existing data or available knowledge. They also integrated web tools into this so that you can do a web search and make a more informative output, but still it's based on whatever data that is available digitally. So that's the point to remember. Which leads me to talk about what are the limitations and considerations when adopting artificial intelligence in our work. Especially, I know in the industry and in the domain of transport and logistics. One consideration or the limitation, not a limitation, but a consideration would be, what is the legal liability? Now, if you are using an artificial intelligence, system, and let's say the delivery doesn't happen on time, or you get a broken item delivered anyway. So what is the legal cost that you are going to pay? And that is one thing. And if you are using data from others' data to train your models, what about the copyright? So the recommendation is we will have to balance safety with innovation. Yeah, it sounds like AI is very powerful and it's very interesting and exciting to use. At the same time, we will have to very carefully understand and identify what are the tasks that I can let an AI handle and what are the tasks that the human would have to handle, and balance safety with innovation. The other consideration would be the data management. Because the more quality the data is, better and effective the AI would be. So if we are considering adopting these AI solutions, or if you are considering using AI models in your work, maybe if you are a research student and you are considering of using AI models in your problem, in your research question, it's important to pay attention to the quality and the diversity of the data, which relates in fact with the fairness or the fairness in the models, and which relates with the bias that can be in the model. So can you apply, you train a model on a publicly available data set that is coming from the United States of America, and can you give recommendation to a system that is being adopted in Sri Lanka? How generalizable your model is. And if you are developing your own system, your own data, how much quality your data is. The other consideration would be to look at the change of resource allocation, because if you are thinking of this is for in the industry, and if you are in the top management and you are now considering adopting AI into your organization, the current resource allocation would change. You would be maybe investing more on AI systems than less on the humans. So which would require some strategic planning, which I'm not an expert to advise also. I think, that is something to consider. The other consideration would be the skill gap. So some of these systems, generative AI-based systems, or maybe if you're thinking of augmenting your existing system with an AI system, the existing staff as it is may not be ready to adopt them. So you would have to consider upskilling the workforce, providing them with training, etc. And the other thing would be, another consideration would be the high complexity of the models. For example, if you are using a predictive model to make a certain decision, you are using a machine learning model to forecast the demand for the next week, and you are using it to decide, okay, where to allocate which vehicles or which items, how to change your marketing plan, I don't know. So, but you are deciding on that a machine learning model to do all those things. And it can be very complex. And so if you are an engineer developing a solution, you would like to develop an explainable model. So not only a very good, well-performing machine learning model, but also a model that you can explain. If it is predicting the demand is going to be 10,500, why it is going to be 10,000, why it is predicting 10,500. If you go a level up, if you are not like an engineer who is really developing the solution, but you are the user or the one who are deploying that solution in your organization, the model is complex. You don't really, maybe it's difficult to understand, but you can still try it out, but with careful evaluations with appropriate metrics. So these would be the considerations in adopting AI. And coming from Gartner, this shows what sort of, this is actually a supplement of what I discussed. So depending on, first, I think we'll have to understand what sort of human input, what sort of machine input I can allow in these different tasks that I'm looking at. And then you can look at, am I looking at a decision support system, or what I need is a decision augmentation system, or I'm looking at fully autonomous system. As a guideline, so the starting point would be, of course, to identify the needs and goals. And then if you're thinking of building your own models, in-house models, you'll have to think of building a strong data foundation. And of course, partner with the right AI experts, the people who people who are experts of how would be able to provide you with the expertise to sufficiently understand the system that you will be using. Another recommendation usually given is to start small and scale up. Start with solving the most obvious problem or the most simplest problem, and then scale up. And of course, continuous evaluation and improvement. With that, I'll wind up my talking. And while I thank you all for the attention, and of course, the research work that I presented, they are not all my own work. So I thank my researchers and the colleagues who are collaborating with me. And of course, I am immensely grateful for this opportunity that was given to you to talk on this topic. And I hope it was helpful. But please let me know through the feedback so that what else I would know what else I should be talking to a similar forum, and how ourselves can make us useful for the industry who are really doing the job out there as people in the academia. So your feedback will be very useful to me. With that, I'll wind up I'll stop talking.
Ladies and gentlemen, thank you for your participation.